Welcome to ISL Enabled Virtual Lab of CSIR.
Hello, welcome to the tutorial on time synchronization and its application. Time synchronization is very critical in many applications like internet, stock exchanges, power grid, satellite-based navigation etc. In this tutorial, let's see now what are the basic components of a clock and various factors affecting the performance of the clock. A clock is a measuring device which measures the time intervals in seconds and displays it in terms of predefined minutes and hours. A clock is composed of three important components. First, it has a periodic source of oscillations known as an oscillator. Second, it has a counting mechanism for counting these oscillations and generates signals every second. Third is a display mechanism where the seconds are displayed in terms of minutes or hours. A clock just displays the physical phenomena, time period, which we can feel, but it actually measures its inverse phenomena, frequency. The accuracy and precision of a clock depends on the quality of the frequency source and how precisely we can measure the frequency. Oscillator. Oscillator is the heart of a clock. It generates constant, periodic oscillations with time period t. Examples of this periodic oscillators which are used for defining the time interval 1 second are a simple pendulum, where 1 second can be defined as one time period of its oscillation, i.e., 1 second equals t. The planet Earth, where 1 second is defined as a fraction of a day, i.e., 1 second equals 1 day by 86,400. Considering the length of the day to be constant, quartz crystal oscillators, which are commonly used in wristwatches and wall clocks, it is an electronic oscillator where 1 second is defined as 1 second equals 1 by 32,768 Hz globally. The four basic parameters of the oscillator which directly affects the performance of the clock are oscillator frequency, phase noise and drift. Let's see the effect of frequency of oscillator on a clock. If an oscillator generates 2.1 Hz when compared to the standard 2 Hz oscillator, the phase difference of the oscillations increases linearly with time and thus the time difference between the two oscillators. We can see here that for every second, the clock is running 50 milliseconds faster. Hence for every 1 hour the clock runs faster by 3 minutes. Now let's see the effect of phase difference of oscillator on a clock. If the two oscillators generate signals at same frequency of 2 Hz, but if they start at different timings, which is called the initial phase difference, let's say 30 degrees, then the phase difference between the two oscillators remains constant forever and thus the time difference. We can see here that the clock is running 42 milliseconds faster for every 1 second and it will be 42 milliseconds forever. Phase noise. Phase noise is a random process which adds noise to the signal for every time period. For example, an oscillator with a phase noise of plus or minus 20 degrees generates output with random phase shift from plus 20 to minus 20 degrees for each time period. We can see in the phase difference plot this random phase noise of the oscillator. This is reflected as timing jitter when we see the time difference of the clocks. Drift. It is the systematic change in frequency of an oscillator over a period of time. It is caused by aging, environmental changes and other internal factors of the oscillator. Now after getting familiar with clock and the four factors affecting its performance, let's move on to synchronization and synchronization. Synchronization is matching the time of two clocks perfectly. That is, every second of the two clocks should be in sync. Synchronization is matching the frequency of the two clocks. Generally, synchronization is easy to achieve than synchronization. Now it's time to play and learn. This interactive learning game has 4 levels, showing the 4 factors affecting the clock. Oscillator frequency, phase difference, phase noise and drift. In level 1, you can play with oscillator frequency. In level 2, you can play with frequency and phase difference. In level 3, you can play with frequency, phase difference and phase noise. In level 4, you can play with all the 4 parameters of the clock. Overview of The game. This is The reference oscillator's frequency. This is The reference signal. This is The test signal. This is The pulse PPS generated from The signal. How fast or slow is your clock? Dynamic parameters, to resume, pause, reset and lock The game. Real-time behavior of your clock and its accuracy.